Hello and welcome to this presentation on Windows programming. Up until now, just about all of your programs that you've created have been of a console type. So you've created programs that have windows that look something like this. And the output is primarily just text. In this course, we obviously want to make graphical output. And so we'll start with a basic Windows type program where we get a very simple plain window as the output of our program. It'll have a title bar, it'll have some buttons on it. You can move it around, resize it, minimize it, maximize it. And if you wanted to go further, you could add a menu and buttons and other GUI type controls. In our case, instead of adding these GUI type controls, what we'll be doing is adding a DirectX rendering window within what we refer to as the client area of this window. So that's the area in white here. Refer to that as the client area. And we'll be adding a three-dimensional view of DirectX rendering in that area. If you're interested in more information on Windows programming, it's a very large subject. We're just going to go over the basics of how to set up a window that we can use as the basis of our DirectX rendering. But if you're interested in more information on this, one of the most well-known authors in this field, his name is Charles Petzold, and he has a lot of different books on this topic going back many years. This is the latest edition of this one. In order to create a Visual Studio Windows program, there's a couple of steps that you need to take. First, obviously, is you need to have access to Visual Studio. And the version isn't really critical. I use on my home machine, I use the 2017 Community Edition. So this is a free edition from Microsoft. You do have to register in order for this Community Edition license to be active indefinitely, but it's a simple registration process. At work, for various reasons, I use a variety of different versions of Visual Studio. Some are more or less compatible with different libraries that we use, and some versions I use go all the way back to Visual Studio 2010, so it's 8 years old now, and we still use it and it works just fine. So the comment here about is the version critical as a question mark. I haven't tested the code that I'm going to help you out with all versions, but I have tested it with 2017 and I believe 2013, 2015 versions, and it seems to work okay. So I don't think the version of Visual Studio will be too critical for you. When you create a new project, so in Visual Studio, you go to File, New Project, and it's important that you make a C++ Win32 project. So in the past you've made a console application, and here we're going to be making a Win32 project. The other thing that's really important is to understand this folder location. This folder location has two pretty important purposes. One is when you go to submit your work, you want to be able to easily archive everything, all your source code and potentially data files and texture maps and so on. You want to be able to easily archive that. If those different files are spread out over different folders, that can be a real challenge. So to have everything in a common folder structure is really important. So knowing where you've made your project is important. So here it's going to be in Documents, Visual Studio 2017 Projects, and it's going to be Win32 Project 1. It'll actually make a folder with this name and put it in here. I'm going to browse and change the location to my GSP 381 folder. So what will happen here is within this demos, I'm going to create this Win32 Project 1 folder. You might call yours Lab 1 or something like that. When I hit OK, one other comment to make is that sometimes by default this create directory for solution is might be checked, and my recommendation is to uncheck that. What that will do if it's checked is it'll actually create two folders with this name, one inside the other, and that can be a little bit confusing. So I recommend to leave this unchecked. When we hit OK, we go to the next screen, and it's got application settings or application wizard, and we click on settings, and it's really important to make sure this Windows application is set, and we want to make an empty project. And the reason for that is if you don't make an empty project, Microsoft is going to generate some extra code files for you that make things more complex for us than necessary. So I recommend you use this. Start out with an empty project. When we hit finish, it goes ahead and creates the folder structure for us. And we can browse and find that. So if we look under demos, we see this Win32 project that was created. And this is the solution file, and this is the VCS project file. And there's some other files that have been created by Visual Studio for us that we don't really care about, but you don't need to do anything with them. Within Visual Studio, this may be familiar to you, you've got different sections in the project for header files and source files, and this is where we'll add different components of our program. So again, we want to make sure it's a Win32 project. Leave this unchecked, this create directory for solution. Make sure you know where your program is going to be created and stored, and make sure we make a Windows empty project. That'll keep things simpler. Another important thing to realize is that the solution folder is what we call the CWD, the current working directory or the present working directory. And this is important because within our program, if we want to read a data file or save a data file, the location of that read or that save will be relative to the current working directory. So what that means is that if we don't specify an absolute path and file name, by default it will start looking for the path and file name that we specify in this current working directory, which is our project directory. In the future, we will have additional data files and actually additional source files. We may have three-dimensional models, textures, audio. We also soon are going to have a shader program, which is in a separate file that has to be loaded, compiled, and set. And again, the other advantage is by having all this in the same location, the same folder, when we go to create a zip archive to turn it in, it's all in the same place. And I'll show you an example of that in a minute. Something else to be aware of is this concept of character sets. I'm not sure if you've had to deal with this yet in your programs, but if you go to Project Properties, oops, we have to click on the project and then go to Project Properties. you'll see this character set, and you can change it to not set or multi-byte or Unicode. In the past, in your programs, you may have changed it to not set, and by default used the ASCII character set. In order to support additional languages, modern programs now use what's referred to as a Unicode character set, which allows for many, many more characters to support foreign languages. It does bring up some additional challenges that we have to deal with. In particular, when we go to create a constant text in the program, one of the things that we have to do is to prefix that text with a capital L. It looks a little bit goofy. So if you would put your name in here in double quotes, and you want for it to be a Unicode string, you put this capital L right in front of it, and that looks a little odd. Instead of using the basic string object, you would use W string. So W is for a wide string, so it's probably a double byte character for each letter in the string. And you would use functions like WSPrintf to create or formatted strings. I encourage you to do some research on these functions, especially the WSPrintf. And one of my favorite places to view this, to do this type of research, is at C++.com. The Microsoft Developer Network, MSDN.com, is also a good place to look up, as well as asking questions on Stack Overflow. Those are good reference places. In here, if we look up the basic function sprintf, it shows you examples of how to use it, and the WSPrintf is really the same. It just works with Unicode characters instead of ASCII characters. And the idea with WSPrintf is you can take a character array and a series of variables and they can be of different type: integer, string, float, and you can create a formatted string, or a string that contains text as well as data inserted into it. And again, the data can be of different types, and it can be formatted to so many decimal places and so on. So this is really useful in creating what we refer to as a formatted string, and then you can use that string and output it to a file or put it on a title bar, something like that. So I encourage you to look up how to do this, how to create a formatted string. There are other ways of doing this, but this is one common way of doing it. And it'll be as part of your assignment to put some additional information on the output of your program. So we'll leave the program's properties set to using Unicode. You just need to be aware of some of the implications of that in how you have to deal with strings and text in your program. So to start in our code, one of the things that I like to do to organize the code is to create within the project folder, is to create another folder called, I call it source, and we put all the source files in there. And we'll start by making, and you can do it here or you can do it in Visual Studio. You can add a new item, And this would put it in the project folder, but I want to put it in the source folder. So all the source files are together. And then later on when we have images, texture maps, maybe model files, we'll put them in a different folder, maybe called data. So you can organize your files. We'll start out with a main.cpp. And we'll add some code. And I've already got this code written, and I'm going to share most of it with you in the files section of the course. And one of the major differences is that we need to include a header file called windows.h. And another major difference is in past C++ programs you've probably seen that you have to have a function called main. In Windows programs you have to have a function called winMain, and this is where the program begins. So far we don't have any code in here. What little we have is commented out. We'll add it. But if we go to build it, you see down here we'll get a Win32 debug build, and it looks like it succeeded. This program won't do anything yet. I don't even think it'll show any output, but we can start with our first Windows function that we can call, and it's referred to as message box. And it does exactly that. It shows a little window with a message in it, and this can sometimes be good for debugging. You can display messages when things go wrong, or if some error checking that you want to perform in your program doesn't work out the way you expect it to, you can bring up a message box and report that. And when you do, the first parameter is what they refer to as the window handle. We don't really have one of those yet, so you can just put a 0 there. The second is again, here's a Unicode string that begins with an L, and this is the message that goes in the box. And then the third argument here is another Unicode string, and that's the title that's going to go on in the box, in the title bar of the box. And then what buttons do you want the box to have, and I just use an OK button. So if we run this, we get our first Windows program, and all it does is bring up this message box that has the title and has a message. And it doesn't seem like it's very much, but this is actually can be really useful, because the message could be a formatted string that has data in your program that's formatted, line numbers, file names where something may not have gone the way you expected it to. So this can be a useful thing for diagnostics and reporting information to the user. And when we press OK, that's the end of our program, and it's done. So that's kind of boring. Let's continue and try to do a little more. I find it useful in our program to create an application class. So this is a C++ class that has variables and methods, and the variables are some of the window methods that Windows variables that we need, like window handles. And then some of the methods are initialization and what we call the message loop and shutdown and so on. So I'll go ahead and do that. We'll make a new header file. And again, I want to make sure it's in the source folder. And I'm going to call this dx11 app.h. I'll do something similar with the source file section. call this dx11 app.cpp. And we'll start off in the header file. We'll do a couple of things. The first thing is to do this. You saw earlier there was this pragma once in there. The idea on a header file, by using what we call conditional compilation directives, either the pragma once or this pound if and def pound define combination, is that if this header file is included in more than one source file, you don't want the compiler to see duplicate definitions, so you have this conditional compilation step in here. So basically everything within a header file should be within this conditional compilation directives. Pound if not defined, pound define, and then a pound end if at the end. And the name that you use here needs to be unique, and so I just use the name of the file with an underscore replacing the periods. We've got some includes, so windows.h we saw before, and then also string, and this allows us to use wstring as well. And then we're ready to add our class. So I'm creating a class named cdx11app, and it has a few variables in here: the instance of the program, a window handle, and an application name. It has some Boolean flags here about whether the application is paused or minimized, maximized, resizing. That'll be useful a little bit later when we start to use DirectX rendering. If the application is paused or minimized, there's no need to do any rendering, so we can use these flags for that. And then the screen width and screen height, we want to be able to set the resolution for our graphics output, and so we need this to size our window when we create it. We're going to have a series of methods or functions within our class, and initially we want to be able to initialize init or initialize our Windows application, and we want to be able to initialize our main window. Shut down, some of the initialization steps will involve allocating or creating resources, and when we shut down we want to be able to deallocate or free those up appropriately. Run, so this will, our game and graphics application will have a loop over and over again where it will continually update and draw graphics, and so this is the running part of that loop. On resize, so this is the function that's going to get called when our program resizes. Initially, when it's created, it'll initially be sized, and that technically is a resize, and then if the user wants to change the size of it, we'll have this resize get called again. Something else that's unique in Windows programming is that because the Windows programs are user interface programs, so because our Windows programs are user interface programs, we have to be able to respond to GUI events. And those events could be mouse button presses and menu selections and of a window resize, minimize, and so on. And this is done in what we call an event handler, and that event handler has historically been called a Windows procedure. And so sometimes that's abbreviated as WinProc. You can name this whatever you like, but often it's something like Windows procedure, WinProc, WinProcedure, something like that. We have a constructor and destructor for the class. Doesn't really do anything. The destructor calls shutdown, which will free up our objects and so on. So the next step will be to implement these methods, these functions. do that, we'll put some code in our C++ file, our class definition file. So we include the header file for the class. We include assert.h, and this is a useful thing in debugging. Sometimes we want to assert that certain things are true to make sure that things happen the way we want them to. We're going to create a global instance of our application class. And we need a global version of the window procedure. And so all this is going to do is take the window handle that caused the GUI event, the message, so this is the type of the GUI event, and the W-param and the L-param are additional, they contain additional information about the GUI event that occurred, like what was the mouse's XY position when the event occurred, or what key was pressed on the keyboard, or what button was pressed on the mouse. We're just going to take that information and pass it along to our Windows procedure that's in the application class. The next step is to initialize our application, and we're going to pass in the instance that we get from WinMain. So this is a handle to the instance of our program. As you know, for GUI programs you can have multiple instances of them running at the same time. So you can have multiple versions of Visual Studio or browsers or so on running at the same time, and this is a handle to the particular instance that's running at the time. We'll initialize the window handle to be null, do some other initializations, screen width and screen height, and then we're going to call our init main window function, and if everything goes okay, we'll return a true. When we initialize the main window, this gets into some of the details of Windows programming that can be a little daunting at first, but most of the time you don't need to change much of this. You just use it, and if you do need to change it, you look it up in the documentation and figure out what parts you need to change. Most of this code won't change much. The first thing we do is set up what's called, or we define a Windows class. So we're defining not a class in the object-oriented sense, but a type of window that we want to create. And the window class structure has style, has a pointer to a window procedure, and that's where we're going to make sure that this name right here, main window procedure, matches this name right here. So this is the pointer to the window procedure function that's going to get called for every GUI event this window receives. We assign the instance of the program to the window class. We can set an icon and a cursor for the window. We can set a background color. This particular color window +1 is white, and there's a variety of defined colors, and you can define your own background color. This really isn't critical because later on we're going to overwrite this with the output of our DirectX program, so it's not critical what you use for the background color here. If you wanted to have a menu associated with your program, you would add the menu resource here, and then the class name, we give a string name for this particular class. We just call it D3D window class. You register this class with the operating system, and then we need to create an appropriate size rectangle. In Windows programming, using rectangles is extremely common, and the rectangle structure has a left, a top, a right, and a bottom integers representing the x-coordinate from the left part of the screen, and the x-coordinate to the right, and the y-coordinate down to the top of the window, and the y-coordinate down to the bottom. In 2D coordinate systems in Windows, the origin is actually the upper left of the screen or the upper left of the window, and y is positive down. This is really common in image coordinates and 2D graphics coordinates. So we initially start out with our rectangle at 0, 0 and screen width and screen height, but because the window has a title bar and a thin frame around the edges, we need to adjust that window size. And so we adjust it by calling this function adjust window rect, and say that we're asking it to adjust that window rectangle based on presenting the window in what they call an overlap style. And when we do that, then the new width is going to be the right edge minus the left edge, and the new height is going to be the bottom edge minus the top edge. Finally, we get to the point where the window is actually created. We call the Windows function create window. We pass in the class name, which needs to match this class name. We pass in our application name, which is going to be the initial string that goes in the title bar. We pass in any particular window styles. This is the position, X and Y position of the upper left corner of the window, and that's the width and height of the window that have been adjusted appropriately. There's some other parameters that we don't need, and we pass in the instance of this particular application. The create window then will return to us a window handle. So this is a number, an integer value that uniquely identifies a particular window. Curiously, the create window function is used similarly to create other types of windows. And other types of windows can be child windows like buttons and menus and scroll bars and so on. After the window is created, initially it's common for a newly created window to not be visible, not be seen, or hidden. So we call the show window function for that window and say show it, let us see it, and we call update window, which forces it to be redrawn for us. And optionally we can set the window position to a different location on the screen if we want to. There's our shutdown function, which really we don't need to do much with right now. Here's our run function. What the run function does is it sets up a really important part in Windows programming, what they call the message loop. And so the message loop gets called over and over again. We're checking for messages that are transferred to our program largely by user interface events. And so while the message is not quit, which means keep going, we're going to look at that message and translate it and dispatch it. And this dispatch process sends the message to our window procedure. And so this section here is the classic Windows message loop. If there is not a message, so peak message will return a false if there's no message to get. So there haven't been any user interface events, there's no messages. And messages are generally processed really fast, so there'll be some time when there's no messages. And in that case, we want to do our game stuff. We won't have any of this just yet, but we will soon. So this is the run function. We're going to define our resize function. Doesn't need to do anything just yet. And then we're going to define our window procedure function. So here's our window procedure, and again it takes the window handle. Usually it's not. Sometimes it's not the handle of our main window. Sometimes this is the handle of our control that caused an event, like a button or a menu item. The actual message itself and additional parameters that can give us additional information about the message. Some possible messages we may want to respond to are size, destroy. This is when that little X in the upper right hand part of the title bar gets pressed. We want to destroy the window. And this is how you end the program. So in your code, if you want to cause the program to end, you call this function called post quit message, and that sends a quit message to your program and causes your program to shut down. This is the more graceful way of ending a Windows program. This message here, wm-get-min-max-info, is used to set the minimum size of a window. Because we're going to do graphics rendering, a lot of times you don't want the window to be really small, so we set a minimum size. You can change that size if you like. So now in main, we need to do something with our application object to get it working. And the first thing we do is create an external reference to that application object. So we use the extern keyword and create this reference to our global application object. It's flagging that as an error because we need to include our application object header file. In WinMain, we're going to take our application object and initialize it and pass in this instance handle, and then we're going to call the run function, which runs the main message loop for us. So this pretty much takes most of the burden of the Windows programming and puts it into our application object that we've defined. And if we did this okay, it builds okay, and if we run it, we get this window here that we can resize, minimize, maximize, and so on. So that's our first Windows program, and this is pretty much what you need to do for your assignment in the lab this week. A couple other things we might want to add to it is the ability to respond to some type of user input. And user input occurs in the window procedure. And so, for example, if we wanted to get or respond to a Windows message mouse move, we could add a message here. And what would we want to do with that mouse move message? We might want to capture the X position of the mouse and maybe display that in the title bar or something like that. So in order to do that, I'm going to create a string. In this case, it's a wide character array. and I'll create a formatted string in this and then set that as the title bar text. How do we get the X coordinate of the mouse? If we go to a browser and type in WN mouse move, we can find the documentation of this at MSDN, Microsoft Developer Network. And it tells you about the message, and it tells you that if wparam has certain values here, then we know the control key is being pressed or the left mouse button is pressed while the mouse is moving. And additionally, it's got some sample code in here that shows you how you can get the X position of the mouse within the window. So we can add in this code, and I called it position X rather than X position. It doesn't seem to like that. So looking through some documentation, it looks like we should use what we call the low word. So the L param here is defined as a long, and so that's I believe it's a 32-bit integer, and you can get two 16-bit words out of 32-bit integers. So the low word will be the X coordinate, and the high word will be the Y coordinate. And now we can use WSPrintf and format something in our message string, and we can put GSP 381 mouse X %D and again, these strings have to be Unicode strings, so you put a capital L in front of them. So what this does is creates this formatted string in this message string variable where the integer X position of the mouse will be substituted in for this %D. And so this %D is a placeholder for a variable substitution, and there's a lot of different types of placeholders for different types of variables. So %C is for character, %D is for integer, %F is for real numbers or floats, %S is for other strings. So you can look these up in the documentation how to use this if you're not familiar with it. How do we output this string? We could put it in a message box, except we'd have to press OK every time the mouse moves. We could put it in the title bar of our window by calling a function called setWindowText, and we pass in our window handle, and we pass in the message string. So now if we build and run our program, you see that as I move the mouse left and right, the value in the title bar changes. So you can see that the mouse coordinate is almost 0 here at the left edge like we expect, and then should be about 800 here at the right edge like we expect, right? 799. So it's 800 pixels wide like we wanted it to be. So this concludes our presentation on an introduction to Windows programming. We learned about the types of Windows projects to make a Win32 project, We learned about Windows class and defining and creating a window. We learned about the window procedure, the event handling, and the message loop that takes place. And this is what your first week's lab is based on, having you create a basic Windows program with some real minimal user interaction. So let me know if you have any questions, and I look forward to seeing your work this week.